हेलो। हेलो। हाँ बोलिए। हाँ हाँ, बिजी होगी, करता हूँ बात, कुछ अर्जेंट है क्या? Hi Sam,
Hello, can you hear me?
yes, I can hear you. Let's start the video quickly and see if it's all okay. Yeah, the video looks okay. Okay, we still have a few more minutes. Let me just, yeah,
Sure.
let's, make it live. And then, so people are watching on YouTube live now, I believe some of them here.
Okay.
Vishesh would not be doing session, I'll be doing session, so we
Okay.
could not, yeah. Yeah. Bit quiet today. I think everybody in the celebration mode.
Yeah, I was also planning. So I wanted to tell you actually, I will be leaving probably. First thing today is like the code freeze for Kubernetes. So I might need to do some work there and might have to leave for Dhanteras.
Yeah. I think I thought the Diwali was on 12th, 16th, sorry. So I thought I don't know something didn't go properly.
Yeah, I also did
Uh,
not know. I got to know because I'm at my hometown now, so my mother told that we need to go out. And I'm like, oh, why? And today is Dhanteras.
okay, okay. Sure, no worries. We just it's about time there.
Yeah.
Okay. Hey guys, good evening everyone, or hi, where are you? So thanks for joining in. In this session, we would be covering Flatcar Linux and KubeVirt. We have Sayan, who would be covering the Flatcar Linux, as you know in the agenda. And I would be taking care of the KubeVirt session. It was supposed to be given by someone else, but for some unfortunate reason, he could not do it. So I will be covering the KubeVirt post the first session. Um, sure. Okay, so let's get going, Sam.
Okay. Thanks, Nipinder. Uh, so I'll just share my screen. Uh, yeah.
Yeah, we can see your
Uh,
screen.
okay. Great. Yeah. One minute. Yeah. So, hello everyone. Good evening. Hope you are doing safe and well, and happy Dhanteras as well, like to all the folks joining. So today I'll be talking about, as Nipendra said, that I'll be talking about Flatcar Container Linux. It's a distribution, and I would be covering on like the legacy part of it and how we are carrying over the whole Flatcar operating system forward. Before moving forward, let me introduce myself. I am Sain Chaudhary. I work at Kinfolk as a Linux software engineer. I am part of the Flatcar team, and in the past, I worked with at Red Hat and various Indian startups as well. So this is a place where I recently joined, but the work has been really challenging and fun, and it's exciting. So I would like to share the journey and whatever excites me over in this talk today. Uh, so, in case you're wondering about the company Kinfolk, so we are a Berlin-based company. The company is a remote-first company. We are a really small team. It's not a very big team, but we have folks all around the world. But majority of the folks are from Germany, and I would say like the roots of the company are from Germany. So that's where it started, and that's from where it started to grow. We are very active in the community, in the open source community. The team, we are actually, there are various teams within the company. We actively contribute in various open source projects. The company started back in 2015, and it's a totally open source company, so to speak. So everything that we do is basically open source, and you might also relate us with different conferences and the meetups that we do, like the Cloud Native Rejects, All Systems Go, O4B, and a few other meetups as well that we conduct. Actually, there is one meetup that would be happening probably later towards the Indian time. So yeah, so we are, as you see, like the technical background, so we are kind of the experts in Linux, Kubernetes, containers, BPF tools, and our kind of the work that we do in open source reflects that. uh, and finally, the open source consulting work that we do, we have a lot of companies under the belt, and with whom we have done some really good works in the past. And so this is how it connects to the core story eventually. So basically the story flows ahead. And CoreOS, in case as you see in the slides, is one of the companies Kinfolk was consulting for, and that's how the story begins. uh, yeah, so CoreOS basically founded back in 2013, if I recall correctly, with the basic foundation or the pillars on which it was built upon was very simple, but the ideology was kind of gigantic of securing the internet or secure the internet. And you might have, if you have read through the blogs, through the social media posts that they do, you might have seen that they have iterated over again and again, that this is the core principle of one of the core principles that they had, which was securing the internet. But so to speak, like, what does it even mean, like secure the internet, right? But I'll probably go a bit into it, not really deep into it, because I have a few other slides where I'll be explaining this into a bit more in detail. But just to tell you, like, one of the major things that comes into any security part, or when you're working on security, is reducing the attack surface. So lesser the attack surface, the less vulnerable you are. The next thing is building an immutable file system, which is the less changes you do, the lesser the more stable it is. And then, as we all know, in the sysop or DevOps terminology, that is the principle of the least privilege. So whoever needs it, you just give the principal access to that particular set of people, or servers, or anything on that side. So keeping it to the bare minimum as possible, and be as updated as possible, so automatic updates comes into that picture. And finally, having a secure runtime, so that everything falls into the whole picture. And yeah, so another thing, so talked about the secure the internet. So the next thing they kind of related this whole thing was called GIFI, which stands for Google Infrastructure for Everyone Else. I would just quote Alex Polvi here, who was the CEO of or who is the CEO of CoreOS. So GIFI is a style of managing infrastructure, the hyperscale companies, like the way hyperscale companies like Google operate, with infrastructure designed for maximum robustness, scalability, security, and reliability. So this is another term that CoreOS folks have talked a lot, and they also coined the term when I read the blog. So this is also they was something they talked about a lot in the blog. So the idea here is that over the years, Google have mastered container-based distributed infrastructure for themselves, and kind of demonstrated a value and method of deploying large-scale distributed systems. So basically, pulling this whole down for a normal person to deploy and get the maximum robustness, scalability, security, and reliability for their infrastructure. So that's kind of the core idea that they had. But what does this stack kind of translates to for CoreOS? So in CoreOS, the stack basically contained of a containerized or optimized operating system. So they brought in CoreOS, which was universally known CoreOS, but then they probably later renamed it to CoreOS Container Linux. Then on top of that, they brought in RKT, the runtime container runtime, uh, which was really up, which kind of set the standard back in 2016, 17 at the back then. And then, as you know, the SCD state store, basically like the way to manage the state in a distributed environment. And then they brought this container orchestration tool. First they went called Tectonic, which was first with Fleet, and then they quickly moved over to Kubernetes. So finally, coming down to the container registry that they built, which had a built-in security scanner, which is primarily the registry called Quay, and then the Clear. So this is the stack that they built over time in a very, I would say, in a very less span of time, which they built for kind of having the Giphy kind of a thing. So this was the platform they were maintaining, the products or the projects that they were maintaining, and everything was growing really great. But then something happened. So as you know, like CoreOS was acquired by Red Hat, and then IBM came along way, a bigger fish came along the way, and ate up Red Hat. So basically what happened was like the acquisition happened continuously, and then we really were not sure about the future. And then so as of today, the stack looks like this. So basically the container Linux, the CoreOS container Linux, it went end of life in around May 2020, towards the end of May 2020. And then the images got removed in September. So everything, so what they did was that everything was merged into Fedora CoreOS. And it was basically like the atomic project, the best of the atomic project, and the CoreOS got merged, and they released Fedora CoreOS. And the commercial support for the container Linux was only available through OpenShift. RKT was contributed to CNCF, which was later retired. And then CNCF was also contributed to CNCF, but it became a really good and kind of the core component of Kubernetes with really active development. Tectonic reached its end of life as well, and all the technologies inside it was merged into OpenShift 4.0. In December 2019, Quay was open sourced by Red Hat. So the whole stack looks like this, and this is where we come into the picture. So we want to take the ideologies and of the CoreOS forward with two of the products that we are building. One of them is the locomotive, which is inherited, or I would say forked off from Typhoon, which is getting built by one of the previous employee of CoreOS, which is kind of the open source version of Tectonic. And then Flatcar is the fork of CoreOS container Linux. So this is the two ways we are taking the whole project forward. And so the reason we brought this together was like we wanted to take the project forward with the same CoreOS values. And we have experience, and given that we actually worked with the CoreOS folks back when we were building with the RKT project, so that was the part where we thought that we can take this project forward. And but we do so the questions that comes into picture is, do we really need the one container Linux? How different is it from a regular Linux distro? So as I told in previously, that few of the things which we recalled was reduced attack surface, immutable file system. So everything comes into picture, automatic updates. So everything comes into picture in this slide. So basically, like, one of the thing that we are doing with container Linux is having reduced dependencies. So the lesser number of dependencies are there, the lessest number of softwares are there. So we try to keep it as core projects as possible, or code packages as possible, so as to have a very reduced attack surface. Anything more than that, you just spawn up a container and use it via container. And this reduces a lot of overhead on the like, basically to make the changes very atomic kind of a thing. And then the container Linux, the file system beneath is totally immutable. You cannot really write anything to it. So as you see there, it reduces a lot of CVEs that does not really affect us. And then finally, you really don't need to bother about the update. So basically, if you just as your mobile, I'm talking of Android because I'm Android user. So as your Android gets an automatic update, similarly your servers gets automatic updates, and if things fail, it just roll back to the proper working state. So that brings down and brings stability, robustness, and you can really scale, because the whole system is very repeatable and scalable. So now, as I told kind of the backstory of Flatcar and how this was inspired, how we were inspired to take the CoreOS forward. So container Linux was based out of Gentoo, and it was kind of a fork of Chrome OS. And then so we took the a few parts of Chrome OS, and Core OS contained Linux took parts of Chrome OS, forked it, and built on top of that. And then when Core OS was announced to be deprecated, we Flatcar was forked and it was born out of it. But one of the questions that I had primarily in my mind when I heard Flatcar for the first time is, what is Flatcar? And this is a very innovative part. So Flatcar is basically this is something I did not know. So Flatcar was basically like, you have the freight wagon. It's like a railway rolling stock on which you put all the containers on top of it. So this is a very brilliant idea to name it Flatcar, and that's how the name got, was Flatcar Container Linux. Now coming down to the way the whole structure is on how the versioning is and everything. So Flatcar essentially has 4 channels. CoreOS had 3. So CoreOS had alpha, beta, and stable. But for Flatcar, we brought in another channel, which is the experimental channel called Edge. So kind of it's a channel where all the experimentation happen, and then the alpha, beta, stable is basically everything new or stable or something that needs to be shipped to stable gets shipped into alpha, and then it matures enough to goes to beta, and then finally to stable. Everything is available on the Flatcar website. You can check out all details in there. Now, what are the available things? So basically, we are available on all the major cloud providers. We is there on our website. So the link that you see is channels.release.flatcarlinux.net. So basically, if you replace the channel with stable alpha, so you will get all the images, the cloud images that you can download and use that on the cloud provider. But traditionally, like on Equinix Metal, Azure, AWS, GCP, they are directly there. You can just go to the marketplace or go to the image listing page, search it there, and you can spawn up a new instance. And finally, like as I told, like Flatcar is automatically updated. So the essential part here is we maintain a public update server. So whenever we push a new update, so so the machines which needs an update, so they directly pull the updates and gets updated behind the scenes, and you will not even get to know about it. It just happens behind the scenes. And the project, which is the Kinfolk update service, I'll talk more about it in the next slide, is also an open source project. So this is it's a totally open source project. So project name is Nebraska, and you can you can use the public version that we have. If not, if you want an on-prem version of the service, you can directly use it as well. So it's a very fine it's the features is basically you can find every update. So if you want to kind of you want to really rate limit through your updates, like if you want to create sets and everything for your servers, you can totally do that and do upgrades and do all the deployments through the project. And it has a very user friendly UI. And so as I told, like the projects the Flatcar projects is essentially being built by Kinfolk. So over the last few months, we have started to build a very dedicated team at Kinfolk, who are totally working towards on building Flatcar Linux, really good distribution, or I should say, like because when CoreOS announced that they would be deprecating container Linux, so they started to like not push a lot of updates. So right now the team is working towards getting more and more packages updated to with their latest version. So that was one of the things that CoreOS maintained, and right now the Flatcar team is dedicatedly doing that. So right now we have set up a completely test infrastructure where we build and test all the infrastructure, and the infrastructure was donated by Equinix Metal, which was formerly known as Packet, and we are really thankful to them. So the current status, I would say, is kernel 5.4 is shipped to stable, and you have also the system D245 shipped. If I guess it was 241 in CoreOS container Linux. So if you are using container Linux, that's 241, if I recall correctly. And if you talk of the alpha channel has already 246 system D, and the kernel is 5.8. And then we have the user space eBPF tooling support as well. The next thing is over this year, earlier we used to pull in all the patches from CoreOS, but over the last 1 year we have tried to maintain like go totally independent. So we are totally on our own, and we are doing releases on a very regular basis, and there is a support infrastructure in place for 24/7. We have, like, right now, after I will share the slide on how the spike happened, but over the last few months we have seen a good number of spike from really large enterprise customers have deployed their servers on like thousands of hosts. And we are also available on most of the cloud providers. If not, we are working on it to make them available. And finally, we are getting a really good community adoption, and a lot of people are actually using Flatcar. So as I told, like, we are available on most of the platforms. Like, you can see the list of the platforms. We are working on the cluster API integration, and it would be landed very, very soon. So yeah, so as I told, like, CoreOS went deprecated around May 2020. So from the time, you can see that spike happening. So 1 minute, sorry. So around Jan 2020, we saw a big spike happening in the number of people converting or moving to or migrating to Flatcar container Linux, and that spike has been going ever since till date. It might be a bit outdated graph, but yeah, so you can see the places from where people are actually using container Linux. Those the big blobs can be data centers, but yeah, so people are using it very actively within the community. Okay, so what is the plans for Kinfolk going forward? So sorry, plans for Flatcar going forward for Kinfolk. So we have a active issue tracker, but we want to maintain a public roadmap, or what are the things that would be coming in, what are the things that would be um, happening, and everything in public, so that more community engagement happens. We are still working on it. And then, as I told, like, we have already updated the kernel, but we will try to move it as soon as possible to the stable. And to speak, like, to talk of the security updates, we have around like 145 CVs that got fixed in the last couple of months. And we also plan to bring in, because this is some request that has come in from the community, to have more better debugging tool support. So we are planning to integrate like KDM support into Flatcar. And we also got one of the other thing was, given the fast pace, few of the companies wanted to have a greater support cycle. So that's where the LTS release comes into picture. So we will be bringing out the LTS, Flatcar LTS, very soon, basically in the next few days, or probably a month or so. But yeah, we are working on that. And another thing I missed out here is the Flatcar Pro offering that we have brought on various cloud providers. Um, right now it's only on Azure, which is basically like it will have Azure Tune kernel and various other things, and it would be provided through a Flatcar Pro offering. And finally, as I told, like we are an open community, we are open to feedback, we are open to all the feature requests that you want. You can head over to the GitHub Flatcar Linux project, and you can fill in your idea. Like if you have some idea that you want to get implemented, you can just go over and file an issue, and we will try to accommodate that within our cycle. So, and that's how we really want to take the CoreOS legacy forward, because the with Flatcar, we want to keep the CoreOS spirit alive, and with Locomotive we want to keep the basically the Kubernetes distro that we want to take it forward. So yeah, so basically this is how we are planning the whole project. And I'll quickly jump over to showing a quick demo. I hope like the demo gods are good on me today.
Okay, yeah. We can't hear you, Sam.
Sorry, is the screen visible?
Yes. Can you just increase the font size, please? Yeah. Thank you.
Okay, so one other thing that I'll so from the OS perspective, I really don't have a lot of demo. Like I would rather say like you can go ahead, try it, and see to yourself, try to spin up a cluster or something on that lines and try it. But I will show you kind of how the updates and everything works as or just the first demo is basically how to you can do the CoreOS to the Flatcar migration. And considering it, I'm a totally uh, new person to Flatcar, I'm really not sure, and this is how I would approach. So 1 minute, I actually should share the complete screen. Yeah, so I have an image. I'll try to uh, okay. Oh, okay. So yeah, so I'll start to spin up a chorus instance. So the CodeRes images are not available anymore, but this is one thing I had around lying around. So I'll just use those images, but in case you already have the CodeRes image, you can just probably go follow from the steps where I actually basically run the scripts that we had. So for the time being, to utilize the time better, I'll just go over and search how to migrate from CoreOS to Flatcar. So this should give you a, if you can see, this should give you a link uh, to our documentation. There is actually a blog as well. I just search for blog. Yeah. Oh no. Yeah. Okay. This was first one. Yeah. So we have a blog on our website. So if you go in there, you have a link. You have basically, there is a script that you can download, and all you need is to run that particular script and reboot it. So as soon as you reboot it, okay. So as soon as you rebooted it, if you have CoreOS Content Linux, it reboots into Flatcar. So now that I have the thing ready, so I'll try to spin the machine up. Okay, so it does ask me for T plus, or better if I do this plus plus. So I'll just SSH into this machine. SSH. Okay. I'll just turn off the screen for a minute. Nipender, how do you stop sharing your screen? Okay. See the button. I'll just 1 minute. Yeah, so I'll just SSH. So I'm inside this machine. I'll just follow the steps which are given in that block. So the first thing is to pull that script out. And if you see here, what it does is that it pulls the public keys and then updates those. So there is a update.conf which basically contains the link to the server. So it updates from where it will basically pull the update. So if you see here, if you did see this particular part, it points to our public update server. So it updates to that part, and then finally it pulls that particular package, and when you reboot, it checks and updates basically this part, actually, like it calls for the update. And then, so let me run the script. Chmod plus x. So pull up the payload. So 2605 is the latest stable version that we have. So it is basically pulling the latest stable version.
So while it's happening, I'm not sure that you have used KubeVirt or not, but is there a possibility to use KubeVirt and Flatcar Linux together? I'm pretty sure it would be because it's a VM creation thing. But do you see have any inputs on that
1 minute.
or any comments?
Can you repeat a question, Nipendra?
Yeah, so what I'm saying is, of course, with Flatcar Linux, we can create the VM instances and then deploy apps on that.
Right.
I mean, I'm just saying that, okay, is there a possibility? I think it's possible for sure that we can use KubeVirt to spin up a Flatcar Linux instance and then deploy Kubernetes on that, maybe.
I personally not used it, but I can probably look into it. But I guess it should be.
Yeah, it should be possible. Yeah, that's
Yeah, it should be
definitely there.
possible, but I have never tried it. Yeah.
Okay, okay. So what's happening now? If you can just kind of
Yeah.
do the
So
change and- yeah.
so I have basically two screens. One is like a machine booted it. So in CoreOS there was no auto login into it. So you had to set a password. So there is a software called Ignition, which is primarily used as a provisioning tool. So the idea is that whenever you are spinning up a new instance, you provision that, and Ignition runs only once. So the second time it boots, it does not basically runs. It's only the first time it does the initial provisioning. And in CoreOS, you did not have the auto login into the QEMU image, but in Flatcar we have added that thing. So if you boot up a QEMU image, you directly logs in. So on the left hand side, you have the machine that I booted up, and then we provide you with the script. So if you or I would say even CoreOS did. So you get a script using which you can start up a QEMU image instance. And on the right side, what I did was I SSH'd into that particular machine. And if you see here, so basically on the right side, it's a CoreOS container Linux machine. And what I'm trying to do is like to update it to Flatcar. So basically I'm going on with the migration steps. There is a script, as I told, that we have written. You just download that particular script for your instances, and then you update the URL to the public update server. And then when you run the server, there is a command which runs the update engine client, and then it pulls the update payload. So this is where it's downloading that payload, and then it automatically schedules a system reboot after 5 minutes. But we can also, if you see here, we can also manually reboot it rather than waiting for that 5 minutes. So on the right side, you see it's rebooting again. So if things go right, this should actually log into a Flatcar machine to you. So the migration from CoreOS container Linux to Flatcar is really that simple. So yeah, I'll log in again. So if you see here, it got updated to Flatcar container Linux. It's just running one script, and it updates to the latest table that we have. And yeah, so now, as I told about the Ignition, so let me show you. I'll just search Flatcar Ignition spec. So it's Ignition is responsible for doing the provision for container Linux. It was we right now support. So right now upstream it is 3.x, right? But we support because it is built upon for Fedora CoreOS, but container Linux had it for the container Linux was using the 2.x. So we support the 2.x one. So if you go to the configuration, you will see like how you can totally configure everything through this particular ignition, be it storage, be it the file system, be it the network, be it directories, anything. So you have like system D, network D. You can create users and everything and through this particular project. Now I'll quickly show a small demo on this. But as I told, like ignition just runs the first time, right? So what it does is that it checks for a file, and for there are two ways to look at it. So there's a config as well. So it checks for that particular config, and then if it's already set to set, then it basically skips it for the next all boots, but you can manually override it. So I'll reboot the server. I'll reboot the server. I'll power off this one. Okay. So I have if you see here, I have two ignition files here, which I wanted to show in the demo. One is to simply update the put in a systemd service file into hello world systemd service file into Flatcar. So I'll try to do this. So yeah, you have so if you do H, if you go through the help, you'll see that you can pass actually through the -i parameter. You can pass the ignition config file. So let's do that. I have the file name as demo1.ignition, and I'll do no graphic. Now, as I told, like we have to update the parameters. So I'll just put in here, because otherwise it won't run. Flatcar.first boot is equals to 1 and 2. So any non-zero number, it if I recall correctly, it's any non-zero number and it runs. So I'll put it as 1 and then save and continue the process. So it's there. I'll try to log in again, and I'm into the machine. So system. Okay, and the name was, I forgot the name of the service. Vim demo1.ignition example.service. So example. So you see that it ignition put in the particular systemd file into the path, and you can get and you see in here that the file is there. Now what I'll try to do is that I'll try to update it to show that how ignition does not update that particular thing again, because it only runs for the first time. So if I suppose update this particular thing to suppose hello world to hello earth, and try to run that particular and try to run this particular thing again, yeah, so okay, sorry. So SSH again. Yeah, so technically it should not. So as I told, like ignition only does the first time. So even though we updated the service file, it did not update it. So basically you have to like spawn up a complete new instance. So this brings the complete immutability factor in, not immutability, rather I would say, like the atomics, like you start everything, the whole machine has to be kind of done again. You can do forcefully changes, but it's not a really good idea to change. But the core idea is that ignition runs only once here. And there is another demo, but I'm almost end of time, so I'll show another quick, not demo, but a small thing that I was kind of working out for a small test. So as I told, like you can use Ansible. So I was working on a small Terraform file for one of my personal projects. So you can download the uh, Flatcar, like I'm using the alpha, so you can directly put it as an image and directly boot up an instance. Similarly, it goes for if it's an AWS, we directly, the AMIs are already there. You can just provide with the AMIs and it will directly create an image for you. So tinker around. Uh, I would not run this one, but one thing I would say, like before ending off or on a closing note, that things are moving at a very fast rate right now. And we are also, like, if you are interested on contributing, like everything is open. As I told, everything is open source. If you're looking to contribute, do come on the IRC channel. We are there on the free node on pound Flatcar, so do drop in there, discuss ideas. We have our GitHub channel as well, not GitHub channel but the GitHub repo. So we are also working on a kind of a kernel hacking doc. So if you're interested in that side, you are most welcome to come and contribute to the project. And yeah, that's it from my side. And if you want to contact me, you can, I go by my first name on IRC, or you can feel free to drop me an email or ping me over on Twitter. So thank you everyone for joining. Any questions
Uh,
that we have? If you, I'm not sure how we will take questions though.
thanks, Aaron. Let me just check if there are questions on the YouTube thing. No, I don't think so. We have any questions for now. I think because I think we have chosen the wrong date today, maybe. But that's fine. If people are going to watch offline these sessions, and then
Right.
I'm pretty sure they're going to learn from that.
Sure.
And sure, they can definitely reach out to post that.
Cool.
Okay. Thanks, Aaron, for joining us. And hope to see you sometime again.
Cool. Yeah. Thanks a lot for inviting me. Yeah.
No
Thanks.
worries. My pleasure. Our pleasure there. Okay,
See you
so
then.
thanks, guys. So I'm just going to take up the next session now. So we're going to now cover on KubeVirt. So I'm going to share my screen and then have some demos also to show. So let me share my screen. Wait just a minute. Let me just change few settings here. Yeah. Okay. Um, yeah, so we had wishes to cover the other session on KubeVirt, but I'm taking the session, but the agenda remains same. And I'm going to go over the basics of KubeVirt, and then we look at few demos as well. Quick intro about myself. My name is Nipendra Khare, and I am founder at Cloudrhythm. We have been providing consulting and training in the area of containers, Kubernetes, and Cloudrhythm for around 5 years now. I am a CNCF ambassador and co-authored the Intro to Kubernetes course on EDX, which has been taken by more than 150K participants, and so on. I also wrote a book on Docker a few years back. It's like ages now, but that's okay. Sorry, yeah. Yeah, so what is KubeVirt, and why it makes sense to kind of run it alongside with containers. So with KubeVirt we can run with KubeVirt we can run VM workload along with the containers. That is what is the overall project is about. That Kubernetes so far we have been using to run containers, and we know how to run the command of kubectl and everything. We have built all the stuff around logging, monitoring, and so on. But then, what if we can bring in the VM workload along with the containers? And that's what the KubeVirt project tried to solve for us. So why KubeVirt? Basically, it might happen that in some companies, not everybody is comfortable with containers, using containers, and it might be happen that okay, not all the application can be containerized also, right? And even within the company, some people might not be interested to kind of take it to the container thing. They want to say, okay, I want to use VMs only, right? Um, but yeah, as things are evolving, we see that Kubernetes kind of is becoming the standard to manage all of our applications, and it kind of reached at a place where enterprises are adopting it for production workload now. And all the enterprises should be having some VM workload, and there might have been some projects like Overt, OpenStack that may have been being used there. But with but if we have both of things, right, we have VMs running and we have a different control plane for that, and we have containers running a different control plane for that. That might be a bit challenging. So we can bring in KubeVirt in place, sorry, and then manage our VM workload with that. Okay. Yeah, so yeah, of course you can use everything and separately, but why not move together? Because that would unify your compute, network, and storage, and you would have a single control plane to control both VMs and containers. So that would be much better. And we have already figured out how to do logging, monitoring, scheduling, and everything on containers, and we know how to do all that stuff, right? And then if we are comfortable with Kubernetes, we can just extend that to manage VMs as well. Okay, so here is the basically infra and workflow coverage convergence. What can happen with KubeVirt? So you have the basically the same physical machines, whatever you might be having, or it can do on VMs as well. So you deploy your OS and then set up Kubernetes along with KubeVirt, and then run both the workloads in parallel there. Okay. With respect to workflow, we are all very comfortable with using the kubectl command, and with that we can create different kind of objects there. Similarly, to create a virtual machine, we just need to kind of create a similar kind of virtual machine, and that would kind of trigger our machine deployments or VM deployment on our environment there, right? So yeah, basically we are kind of converging into the same workflow with respect to containers and VMs there, which is going to save a lot of effort. Um, yeah, so the architecture of Kubernetes, the KubeVirt looks like this. We have been using this application pod, which runs the application containers there. Similarly, what KubeVirt brings in to create a container or a pod, and that pod is going to manage the VM for you. So it's like when somebody asks you to kind of create a VM instance, we basically create a pod, and that pod would run a KVM or QEME managed or a container which will manage that VM for you. So I'll show the next slide, which would make things very clear. So here is what the workflow is going to be. So as a user, we're going to kind of say I want to spin up a virtual machine, and we would give some configuration of the virtual machine, like what kind of CPU memory we want to give and so on. And then we would pass that on to the API server. API server would then have a CRD called word controller, which runs alongside your API server, and it would then create a virtual machine instance. So we have a virtual machine object, which which has virtual machine instance as a template, right? So as we kind of trigger that command of kubectl, it would send that request to create a virtual machine instance to word controller, which would then basically spin up a word controller pod for us, which will create a pod to launch the VM process. So word controller creates that pod. So what happens is we have this word controller, and along with the word controller, we would be running a word handler on each of our node. And that node, and on each node, we would run this word handler as a daemon set. And this word handler, so whenever we send a request to this virtual machine instance, the request will reach to our kubelet. Kubelet would create a word launcher pod per VM. So suppose you are creating 3 VMs, you would create 3 of such word launcher pods. And those word launcher pods are going to communicate, or they're going to create a VM instance with the help of KVM or QEMU there. So word handler instructs the word launcher how to start a given instance. So the idea is that as you create a virtual machine, it would spin up a pod with word launcher, and word launcher would communicate with word handler to get the request how to configure that particular VM. So maybe it's a good time to kind of look at a demo here. So let's try it out. So I'm going to create a namespace just for our purpose. I have a cluster running, which it is enabled with KVM on one of the nodes there. And if I do, I just say a thing called demo here. Okay, let me do a create get. So we did a demo creation, a demo namespace creation. And here we have a configuration file, which let me show you. Yeah, so here is the configuration file for my virtual machine. So I'm going to kind of, let's say, create a kind of virtual machine, and I kind of specify the template for that, like what kind of template or information I want to give there. Then here I'm saying that, okay, I want to create with 2 CPU, and I can specify the RAM and everything also, like I'm saying that run with 2 GB of RAM and so on. And then I'm saying that which particular image I want to use. So what happens is you can pass a QEMU image with KubeVirt. What in this case, what we are doing is we are passing a container disk. This container disk is nothing but it's like a Docker image which contains your QEMU image there. So which is kind of help us to manage these things very easily. Anyway, let's take it aside for now. So then I'm going to kind of spin up this kubectl apply. I'm going to apply this command here on the namespace of demo. So what will happen is, as I'm going to run this command, it is going to create a pod in the demo namespace, which is going to be kind of a controller pod for my VM instance. And as I do that, you would see that a pod comes up, and then pod is then going to create a VM instance for me. Right? So let me apply this. And if I look at kubectl get VM in the demo namespace, we have a VM instance. Then if I look at virtual machine instance, so this object called VMI, and you can see that it is being scheduled down on a given node or whatever node is there. And if I look at now pods in that namespace, you would see that I have a word launcher pod, which I was referring earlier, that we have a word launcher pod on that namespace. And this word launcher pod is going to basically create a VM for us. So let's see. our VM instance now. It is in the running state now. So I can see that my VM instance is up and running. And to connect to that particular VM instance, let me check the name what we have. Okay. The name is this one. So now I want to kind of connect to this VM instance like the way I do with the console to my VMs. So I'm going to use a command called wordctl. This is a command which I can use, or I can use the plugin for kubectl as well. So I'm going to say wordctl console. I'll give my VM instance name and the namespace, which is demo. So as you can see that I have now connected to an instance of the Ubuntu which I had. I can give the password if I remember it correctly. I think so. The password I don't remember, but that's okay. Yeah, I can log in now. So as you can see that I kind of logged into a VM instance which is being managed by the by Kubernetes there, right? So yeah, I hope you get the idea there. What's happening? Yeah, so we push this virtual machine, which kind of the request goes to the API server. From there, word controller creates a pod to launch VM process. Basically, it kind of instruct a kubelet to do that, and then a word launcher would basically get instructions from the word handler to create that instance on the given node there. Okay, so now that's what the overall workflow going to be with KubeVirt. Similar to the way we kind of attach storage to our containers, we can also attach data to our VMs as well. So basically, we can create these VM instances and then attach the PVCs to them, and then have the data kind of point to our VM instance there. Similarly, we have one more thing here. We can basically upload our VM images to something called as CDI. CDI is a specialized, or you can say, a way to kind of upload all the VM images to our Kubernetes cluster, and we can then, while creating the VM instances, we can mount that particular PVC, and then have the VM started from that one as well. So we can do a few things. We can kind of upload these images of our VM instances to the CDI. While creating the VM instance, we can then get that volume. Even we can start completely from that. And of course, we can also have another volume for our data storage and so on as well. So all these things are possible. What we've been doing with containers there, and that's also possible with VMs now. Okay, and once you have this is a very interesting topic here, like how does the network is going to work for our VMs, right? So we are going to create the VMs, but those VMs are being created by that pod, right, which we created. So we create that KubeVirt pod, which basically manages our VM instances. So the traffic from the external world, or the way we have been doing with Kubernetes cluster IP, node port, or load balancer, and so on, the traffic would reach to that KubeVirt pod, and then KubeVirt pod has a mechanism so that it can pass those data or the traffic to my underlying VM instance. So nothing changes as you kind of create the VM instances. You can have the respective services and all that stuff, and your network traffic would kind of come through as usual way. So which is pretty good actually, and this is kind of makes us seamlessly kind of run our VM instances on Kubernetes cluster and have it accessed via the external world, right? So this kind of opens a lot of doors now for different different use cases there. Now, as we are creating the VMs, now we can kind of take some of these VM world or whatever kind of features we can get from the host, like we want to use SRIOV or GPU pass-through and all that stuff. So all that thing is now possible with VMs on Kubernetes. So you can think of having a device on your host system which you want to pass through completely to your VM. That's perfectly possible with KubeVirt. You can set up a similar ways, request and limit for resources as you do with pods and so on. So yeah, so these kind of things are going to be very useful as we kind of make the KubeVirt at par with other VM solutions there. And yeah, so that's there. I think demo we have already kind of covered briefly. Let me see if there are any questions. Okay, so I don't see any questions as of now. Uh, yeah, so I think that's a very short thing for the KubeVirt, but the possibilities are endless with KubeVirt now to run the workload, container workload, and the VM workload together. And future seems to be looking very bright there. So yeah, that's all from our side, guys. If you have any questions, feel free to reach out. You know how to kind of reach out to me or the other speaker. You can reach me on Twitter, or you can feel free to send a request on LinkedIn, and then we can take conversation there as well. Okay, thank you, guys. Have a good day, have a good night, and yeah, see you. Thank you, guys.